Okay, let's start with part 2 of our lecture today, and this will go deeper into the file system, and we'll do more hands-on exercises, so you'll practice some of the stuff that we saw before and some newer stuff. Okay, so we're not going to go too deep into one subject. We'll just skim over many different topics because we don't have enough time. But this will give you the flavor to start exploring if you're interested on your own. So we spoke about the history so far and some highlights and the Unix philosophy and the way of doing things, and those things will be evident in the stuff that we'll do this session, so I'll mention it when it comes along. So let's start by looking at the structure of the system schematically. The outer level is where we are, where the users are interacting with the operating system. We write programs, hopefully in C, because that's the language that's preferred by Unix, or we write shell scripts, and those reside on top of everything else. Then the green layer shows the shell and its utilities, which some of them we'll see later on, but as we mentioned before, the shell allows us to interact with the core operating system, with the services that the kernel provides. And then internally we have the kernel, which does more things that are not so important right now, but it interacts with hardware. So in a sense it does it pertains to everything that we do, because if we have a C program that reads a file, for instance, it's got to interact with some hardware that's connected to, if the file resides on an external device, or even if it resides on the hard drive of the system, it's still considered the device, and the kernel must do the interaction between the program and the file that we're about to read or write, or other devices as well. Okay, so what are the kernel's functions? In general, it deals with the file system, and we'll see that the file system doesn't include only internal files, but it also includes external devices, and it's basically an abstraction of whatever is connected to the computer, like terminals and hard drives, etc. We'll see it later on. Another item that the kernel takes care of is process management. We discussed it a little bit, and especially we mentioned the inter-process communication, like piping, for example, memory management, paging, if you're familiar with paging. Paging means that each program that runs on the computer is basically seeing the entire memory as its domain, and we can have multiple programs running at the same time, and the operating system manages the pages from the program that need to reside in memory in order to execute, and it swaps pages in and out without the programs noticing so much, because it's scheduling it in such a way that a program in execution which needs resources and needs to execute commands is fully loaded into memory, and if the program waits or has some delay, then it can swap the pages of the program out, and this is a longer discussion than we plan here, but anyway, that's part of the kernel's job. And it's Unix has different flavors, as we saw before, and in the different variations that Unix and Linux have, the functions could be different, and the implementation of the kernel is different from system to system. So let's go on. Now let's go into the shell, because the shell will be our main interaction with Unix, so we have to understand what's going on in the shell. And the shell is something that we work with, because if I can bring an analogy to Windows, I could say that it's probably a combination of Windows Explorer, Internet Explorer, and Notepad, and the Start button. So everything that we do on Windows starts from the Start button. Everything that we do with Unix, we do inside the shell, and the shell is responsible for executing programs, managing files, managing processes, and the shell is basically a program that runs constantly in the background. Once we log into the computer, the shell is running and is waiting for our commands. So it's sort of replacing the GUI interface, if you will, that Windows have or Mac has, and it's not GUI, but it's a line command, but it's very powerful, and there is some compensation for the fact that it's not a GUI. Okay, if you look at your screens, if you logged in and you started Fedora Linux, basically what you're seeing is the shell and the prompt, and it's ready to take commands, which we'll start working with in a second. Before that, let me just mention that the shell has different flavors, and there are several different shells that are used today on different systems. One family of shells is called the Bourne shell family, which is very popular, and the Bash and Korn shell are very similar to the Bourne. Actually, it's part of the same family. The C shell is slightly different, and the enhanced C shell. But there is a standard that almost all of them adhere to. It's called the POSIX shell standard, and almost every command that Unix has supports the POSIX standard. So, and every command that we will work with is also in POSIX. So all the flavors of the different Unix systems or Linux will accommodate the simple commands that we will work with. So here is what I mentioned before. The shell is basically running in the background. It's sort of looping in place. You see there is a command here, while, read command, parse command, execute. So we'll see shortly that when we enter a command on the command prompt of the shell, it does something, and then it returns back the prompt. So this is what I mean that it's in the loop. It's like sort of an infinite loop until you get out of the system, and it allows you to give commands, get responses, give more commands, etc. Some of the useful features of the shell are in command history. If you type in history, you will see several hundred commands that you typed in before. It could be over a few days, over a few weeks, and sometimes you need to execute a command from the history without repeating it. If it's especially a long command, then it will be useful to retrieve it from history. And also what the shell does is file expansion, and let's see what file expansion is. For instance, let's create ourselves a file and if you can go to your prompt and type the command ls for listing, and ls will show you what you have on the current directory that you're working with. And if you want to know what that directory is, you can enter the command pwd, which stands for present working directory, and it will give you the directory if you don't see it already. So under this directory we have all those files that were listed above. Now if we want to see a longer version and more information about each and every file, we can say ls -l. L stands for longer or long, and this will give us each and every file with some more details, and we'll soon see what those details are. But for now, just remember that if you want to see more information about a file, ls-l. Now there is another option that's useful. If you want to see files that are hidden files, you can type in ls-al, and just in general, those options that I'm providing the command ls, like a and l, which are preceded with a dash, it really doesn't matter what the order is. They work together whether you put LA or AL, and you can see that it will give us the same result. If you hit enter with -AL, the additional stuff that it gave us were the dot, which stands for current directory, and the .. which stands for parent directory. We'll see that shortly, but let me just reiterate that thing. If I put the options the other way around, instead of AL, LA, we get exactly the same result. So you don't have to memorize what comes before what, and also we'll touch upon that a little later, but just briefly I'll say that if you're not sure or you don't remember the exact options of a command, there is something convenient that Unix provides. It's called manual pages, and the way you work with it is by typing man and then the command that you want to read more about or look up some options. So in this case it was the listing command. Manual for ls gives us a very concise format of the command with highlights and gives us the options, and if it's more than one screen we hit the space bar and it scrolls down and scrolls down. If you want to end it, we just press Q for quit. It goes back to the prompt. So now let's see what the file expansion of the shell is, as I mentioned a few moments ago. So let's create two new files. And we can create a file without any data in it, and we'll just give it a name with the command touch. So let's do touch D1, and I can do more than one command on the same line if I separate them with semicolon, touch D2, semicolon, and touch D3. Okay, so I've created 3 new files, D1, D2, D3, and we'll talk about the way we name files and the legal symbols for a file a little later. I just want to show you one thing here. So now if we do ls, and let's say we want to see all those D's together, we can use a wildcard character. We can do D asterisk, and it gives us the D1, D2, and D3. So the asterisk stands for any number of characters and any characters. So the 1, 2, and 3 showed up. If I add another one, if I add another file and call it df, for instance, and then I repeat the ls command. By the way, the arrow up will bring back the previous command, and more arrow up goes back to the previous one. So if I do again ls d asterisk, the shell will expand it to D2, D1, D2, D3, and DF. Everything that starts with a D, basically. And I can also combine what I did before, which means ls minus la and D asterisk, and then it will give me the longer format of those D files. Now, I can do another thing. I can use a question mark instead of an asterisk. Question mark stands for one character. So in this case, if I do question mark, I will get the same result because all those files have 2 characters. But if I create another file that's called dff, and then I'll use the question mark, I will not get the DFF, but I will get the first 4 that I've created because the question mark stands for one character. If I go back and put the asterisk, then it will give me everything because, as I said, asterisk stands for any number of characters and any characters. So this is the difference between the asterisk and the question mark. The question mark is good if you know the length of the file and you want to just hone in on certain files that have a certain length. Let's say you want all the files that have 3 characters in them. So you can say ls and then 3 question marks, and in this case I got the DFF and a couple other files that I have here. But you see that they have precisely 3 characters. As we said, the question mark stands for one single character and it must be there. And by the way, the asterisk can stand for no character as well. So if I create a file that's called D, and then I go back and try to list the asterisk, it will include the D because the asterisk can stand for null as well. You can see the first one is the D, and on the other hand, the question mark will not capture the D alone. It will only capture the ones that have precisely 2 characters in the name, which are D1, D2, D3, and DF. Okay, so let's go back to our slides. And let's go to the next one. Okay, Unix has quite a bit of quite a few editors that we can create files with. So far the files that I've created were empty. I just typed touch, and if you were trying to look at those files, they had nothing in them, just the name. But we can edit files with several editors. I found out that on this version I can use VI. VI is a very powerful editor. It's a little bit cryptic, and it takes time to learn it. You have to invest several hours, but if you want to know VI, you will be rewarded because it's, as I said, very powerful. It has a lot of options. It's much better than editing on Windows with Notepad or Word or almost any integrated development environment is inferior to VI. VI, the complexity of VI comes from the fact that it's a modal editor, which means it has different modes that it can take, and you can have insert mode or input mode, and then command mode and EX mode. So it's definitely not for the faint of heart, but like I said, it's well worth it if you're really into it. So I'll try to give you a crash course on VI, which will take us about 2.5 minutes. And let's see, I have another slide, I think. I thought I had another slide about VI. Okay, so let's do it without a slide. We can just simply go back into the shell, and I'll just give you a few things that you have to know in order to create files for this class. So the first thing we do is we type VI and we give a name, and we can use one of the names of the files that we've created, like D1, or we can create a brand new file. Doesn't matter because this file is empty. I only did touch D1. So it opens a space, and before we start typing data, we have to hit I for insert or input, and then you'll see at the bottom that it says insert. So now we're in insert mode, and we can type in once we finish typing in data, we can go to the next line. We can enter more, and we can continue to edit it. Just simply we can go back with the cursor, we can erase, we can insert stuff. Same as what you do with Notepad, for instance. Once we're done with insert mode, then we hit escape, and then escape allows us to go into X mode, and in X mode what we type is colon. Colon will place the cursor at the bottom, and then if I type the letter X and hit enter, it will save this file and get out of the VI editor. Actually, it's VIM, it's improved VI, but it's the same concept. So all you have to know is colon X, hit enter, and the file D1 has been saved. And if we want to look at it again, we can do again VI D1, hit enter, and you can see the file. And if we want to go back to edit, we just do insert, and then we start navigating. And there are many more commands that you can use, literally dozens and dozens, maybe even hundreds of combinations. But like I said, it's not. We don't have enough time to go over many options. But this is sufficient for file creation for our exercises here. So again, escape and colon X, and this is our crash course of VI. Let's go back to the slides. Okay, spoke about VI. Some special characters that Unix is using. We mentioned the question mark, and we mentioned the asterisk. That's also called a globing character, and there are a few more that we'll see over here. One very important is the pipe, which is the vertical line, which is next to the backspace on the keyboard, shift, and above the backslash. The pipe is a character that allows us to connect programs, and let's do an example with the pipe and a couple of commands that are going to be hooked together. So let's go back to our shell, and let's create ourselves another file. So we'll go back to VI, call it foo, whichever name you want, and let's start inserting Let's start inserting. First line will be Z, then A, then another A, then Y, then C, and that's it. Escape and colon X, and we have a file. And if you want to look at it again, make sure that it was created, vi foo, and we see the file, get out with colon X, and now we'll see a command that shows us a file. In Unix it's called concatenate, and it has an abbreviation cat. Give the name of the file, and it lists a file right here on the screen. So now let's try some piping. Let's do cat of foo, and then the pipe sign, and then we do sort, and hit enter. Look at the file before the sort. We have the Z at the top, and after the sort we have the A's on top, and then the C, then Y and Z, sorted lexicographically. Okay, so now let's add another command. We see that we have twice A. Let's say we just want unique values, then we can pipe it into unique without an E at the end, and this will show us unique lines. If there is no other specification, it uses the entire line for the sorting. There are ways of limiting the sorting keys and working with sort has a lot of options. If you want to see them, you can do man sort and read through it and look at the options, or if you just quickly looking for something, then you can just browse it and Q to quit. Okay, let's go back to the presentation. We'll see more of the special characters later on. Okay, what is shell scripting? So far what we've done were individual commands on the line, and the last example was connecting several commands with the pipe symbol. But a shell script is actually like a program, like writing a program. For example, if you need to automate some task or do something more significant than just give a command and manipulate a file, I can give you an example for a script. I wrote a small script that converts files from a Mac format to Windows format, text files, because Mac has different control character for a new line than Windows. If I try to just transfer a Mac file into Windows and open it with Notepad, the entire file will reside on one line. So it will be one long line of thousands and thousands of bytes. So in order to avoid that, what I did is I wrote a small script that takes the Mac file as an input, and what it does is it identifies on the Mac what is the end of line, and it inserts the equivalent of end of line for Windows. And I can show you that script. I probably have it here. I will import it.